Hey everybody, I wanted to create a quick video to kind of help with solubility curves. After midterms, I found that this is one of your weakest areas. So what I've done is I wanted to kind of go through and give you a tutorial, give you some example questions, and show you how I'm getting my answers. So I'm going to start here with just a very simple solubility curve. This is for KNO3. We'll get to table G, which we've been looking at a little bit later, but I wanted to walk us through this one first, okay? So with any solubility curve, the first thing you have to know is, well, where everything is. So you've got temperature along your x-axis, and you have solubility in grams up the y-axis. Now, most of the time, your solubility curve is going to be out of 100 milliliters of water. You always want to check that, but for the most part, this is what you are going to see, okay? Now, to read a solubility curve, there's a couple things you can look for. You can look for how much you can dissolve at a given temperature, or you can look at the concentration of the solution. When you're looking at concentration of a solution, you're looking at how far away from this line you are, or if you are on this line. So for KNO3, so to help you kind of see what I'm talking about, I'm going to pull up this image here. If a solution is on the line, so if I go across to, let's say, 20 degrees, and I go up to a specific amount, if it touches the line, that means it is a saturated solution. I can dissolve no more solute in this solution. If I continue to dissolve or try to dissolve more solute, then you get what you call a supersaturated solution. Anytime we're looking at concentration and your amount or point falls above the line, it's considered supersaturated. Now, sometimes you'll get a dilute solution or an unsaturated solution. These solutions are one that at this temperature, we could actually dissolve some more solute. We haven't put enough in for it to be saturated. So it's going to fall below the line. So if it touches the line, it's saturated. If it's below the line, it's unsaturated. And if it's above the line, it's considered supersaturated. And that will be your response if I want to know the concentration of a solution. So let's take a look at this question. It says at 80 degrees, 150 grams of KNO3 is dissolved into 100 grams of water. What is the concentration of the solution? That word concentration should let you know, okay, I'm going to say saturated, unsaturated, or supersaturated. Do not let this right here throw you off. This 100 grams of water is just stating what we already know, what our graph already tells us. So this information is actually not important. So what I'm going to do is I'm going to come up here and I am going to strike through this, just like if you would with a pencil. Because we already know this information, that means I don't have to use it. I shouldn't use this over here to answer my question. So I want to know at 80 degrees, I dissolved 150 grams. What is my concentration? Once again, when it's looking for concentration, you're telling me supersaturated, saturated, or unsaturated. You always want to start with your temperature because it's along the x-axis. So I'm going to go over to 80 so you can kind of watch my mouse here. I'm going to go over to 80. I'm going to stop because that's my temperature. Now, just like with a line graph you would read in math, we're going to go up the y-axis and we're going to go up to 150 grams. Now, for those of you who don't know, the 150 grams is how much I put in. So we're going to go over to 80 and we're going to go up to 150. You'll notice where my mouse is pointing is where the two lines meet. 80 here, 150 here. You'll notice that point is below the line. This means the solution is unsaturated. If it falls below the line, it's an unsaturated solution. All right, so that's how we find concentration. Now, what if we're looking for grams of KNO3? How much can I dissolve? So looking at the second question here, It says how many grams of KNO3 can be dissolved in 100 grams of water at 65 degrees Celsius. Once again, this information here is just restating what we already know on the graph. So just like I did a few minutes ago, and you can do this with your pencil in your notebooks or anytime you get a problem, you can cross this out. I do know that on the EOC, you also get a cross-off tool to help you kind of filter information away that you don't need. So once again, this information is not important. All I want to know now is how much or how many grams can I put in at 65 degrees? I'm not going to answer with saturated, unsaturated, or supersaturated. Any of these questions need to be answered with a number. So once again, I'm going to answer this question, I'm going to start with my temperature because I need to find my temperature first on my x-axis and go up. So I'm going to come over on my graph and I'm going to go over to 65 degrees. So it's about right here. Now, you're going to have, your numbers may come off like one or two different than mine. That is okay because most of the questions you'll see will be multiple choice. So you won't have to really worry about that. You'll find the one that's closest to my response. So now what you're going to do is you're going to go straight up. Once again, I went over to 65 and I'm going to go straight up. Because we're looking for how much we can dissolve, we're going to go up until we hit that line. And you can see my mouse here. I'm touching that black line and I'm going to stop. Where I stop at is how many grams can be dissolved at 65 degrees. So I'm going to follow over. I'm going to go over here. You can watch my mouse. And I'm going to say, I'd say about 110 maybe a little on the high side there. But 110 grams can be dissolved at 65 degrees. So I'm going to walk you through that again. I'm going to go over to 65 because that's what my problem wants to know. I'm going to go up until I hit the line because we're looking for amount or grams that can be dissolved. So we're looking for saturation. And we're going to go over to determine that number. And it's going to be about 110. So take a second, take a minute, go back and look at those questions and get comfortable with this one line. Once you're comfortable with it, go ahead and move on to Table G. Table G looks a little bit more confusing, but don't let it confuse you. Okay? Yes, there's a lot more lines here. We have several SO2, KClO3, sodium chloride. You have lots of different lines, but you read it the same way. There's no difference in how you read it. All you have to remember is to look for the line that you're actually looking for solubility for and kind of ignore the rest of them. What I would encourage you to do on your own paper is highlight these lines a different color so that it'll help your eyes kind of stay tracked for what you're looking at. So to give you some practice with this one and give you some examples, I've got a couple more problems here. And these are once again in your packet. So it says if 140 grams of NaNO3 at 40 degrees was placed in a test tube, how much precipitant would be at the bottom? Okay, anytime we're looking for precipitant, when you see something like this, and I'll turn that back to black, let me highlight this, you're going to subtract. That is an indicator you're going to have to subtract because I want to know how much is left. So to do this, you have to find, well, how much is saturated at 40 degrees? Before you can do anything else, you have to know the saturation point. That's always your first step. So just like we did up here with our KNO3 graph, where we found our saturation point, we went over to the temperature and up, you're going to do the same thing, but this time with NaNO3 and 40 degrees. So I'm going to pull up Table G here. And I'm going to start by finding my line. Here is NaNO3. All I care about is this one line. I don't care about any other lines on the paper right now. So I'm going to do just like I did. I'm going to go over to 40 degrees, once again along the x-axis, and I'm going to go up until I hit the saturation point. Remember, the saturation point is where it touches our line. So I'm going to keep going, follow my mouse here, and I'm going to go until I touch that line. You'll notice I skipped all the other ones. I only want to know what the saturation of NaNO3 is. So if I touch the line, you'll notice it's about 105. We read it just the same way we did KNO3. So we know it should only dissolve 105 grams, but we put in 140. So this is where we're going to need to subtract. So we would take the amount we dissolved, so the 140 grams, and we're going to subtract the 105 grams. Remember, this is our saturation point at 40 degrees. That's where this number came from. So if I were to subtract the two, you should get, excuse me there, let me put an equal sign, 140 minus 105 should give you 35 grams. This tells me that I put in 35 grams too much, and this is how much would be sitting at the bottom of my solution. Remember I gave you the example of my Dunkin' Donuts coffee, that when I get it in the morning, there's like sugar piled at the bottom. That sugar at the bottom of my coffee, that's the precipitant. That is the amount that did not dissolve. Now, you're going to use these same techniques to answer any question that's requiring you to look for precipitant or precipitate at the bottom. So here's a different style question, but you do the same thing. A saturated solution of NaNO3 at 70 degrees was cooled to 30. How much precipitate would form as the solution is cooled? Once again, we have to know, okay, how much can I dissolve at 70? And then we have to know, well, how much can I dissolve at 30? Because if we're looking for precipitate, we know we have to subtract. Well, what numbers am I going to subtract? You never subtract temperature because we're not looking for the temperature. We're looking for saturation. So the only numbers you should subtract are your saturation points. So doing just like we did a few minutes ago, you're going to need to find the saturation point at 70 degrees of NaNO3. So I'm going to go back to table G. So I'm going to go over to 70, and I'm going to go up to NaNO3. And according to our graph, it's about 135 grams. So 70 degrees, I should be able to put in 135 grams. Now I need to find the saturation point at 30 because we're wanting to know the difference between these when they are cooled. So going back to table G again, using the same technique, I'm going to go over to 30 and I'm going to go up until I hit the line. Once again, I don't care about any of the other lines, just NaNO3. And I would say it's about, say, 95, just to be on the safe side here. It probably is around 97, but we'll use easy numbers for right now. So we'll say it's approximately 95 grams. To find out how much would be left, now we can subtract. So 135 minus 95 will give us 40 grams. This is our answer. We know now that if I were to cool a solution of NaNO3 from 70 to 30, 40 grams would settle out into the bottom. Take some time to look back over how I've walked you through this. If you have any questions, please let me know. But hopefully this will help you better understand how to read a solubility curve.